Have you ever wondered how an AI can answer really specific questions about, say, a private document it's never seen before? Well, the magic behind that involves two key ideas: retrieval augmented generation, or RAG for short, and vector databases. Now, that sounds super complex, I know, but it's actually surprisingly intuitive. Okay, let's dive right in and break down exactly how modern AI is learning to read.
So, here's our game plan. We're going to start with the big problem: why computers and language don't always get along. Then we'll look at the solution, this amazing GPS for words called Embeddings and this smart library you need to store them. After that, we'll see how it all comes together in an open book exam for AI, and to wrap up, we'll even check out the toolkit you would need to start building this yourself.
All right, so first things first, we really need to get our heads around why computers get so tripped up by human language. See, for you and me, words have meaning, they have context. But for a computer, text is just a bunch of letters, one after another. And that creates a pretty big problem. I mean, we've all been there, right? You're searching for something, you use one phrase, but the exact file you need uses a synonym, and poof, your search finds nothing. This happens because old school search is totally literal. It's just looking for an exact match of letters, not the actual idea you have in your head.
And this slide just lays it out perfectly. On the left, you've got traditional search, which is basically just a spell checker. It's looking for that exact sequence of characters, MOBILE. If they're not there, it's game over. But on the right, you have vector search, which is playing a whole different sport. It gets that mobile phone and cellular device are talking about the same idea, even though the spelling is completely different. So how on earth does it do that?
Well, the secret sauce is a concept called embeddings. You can think of this as the universal translator that finally lets computers understand the meaning and the context behind the words we use. An embedding is really just a list of numbers. It's what we call a vector, and it acts like a mathematical fingerprint for meaning. So instead of storing the letters DOG, the computer stores a set of numerical coordinates that captures the very essence of what a dog is. Honestly, this is the best way to think about it. Just like a GPS coordinate pinpoints a very specific location on a map of the world, an embedding pinpoints a very specific idea on a giant map of meaning. It turns abstract concepts into a numerical address that a computer can finally understand and work with. Now, check this out. This is where you can really see it in action. Look at the coordinates for apple and banana. See how similar those numbers are? That's because, conceptually, they're both fruits. But then look at the coordinates for truck. They're completely different. The computer can tell just by looking at the numbers that these two ideas are miles apart on that map of meaning. And this is where it gets absolutely mind-blowing. This system is so good at understanding relationships that you can literally do math with words. If you take the numerical coordinate for king and you subtract the coordinate for man, then add the coordinate for woman, the new coordinate you end up with is closer to queen than anything else. This is proof that the AI isn't just memorizing words, it's genuinely understanding the abstract connections between them. Okay, so we've got these incredible meaning coordinates for all our words and ideas. That's great, but where do we put them all? You can't just dump millions of these into a regular database. No, you need a special kind of smart library, a database built from the ground up for this new way of thinking. A traditional database is like a very rigid librarian. If you don't give them the exact title of the book, they can't help you. But a vector database, that's like a brilliant, intuitive librarian. You can just describe the idea of the book you want, something about adventures at sea, and they know exactly what you're talking about, even if you never use the right keywords. So how does our smart librarian actually find that perfect book? It uses a really clever trick called cosine similarity. Now, instead of measuring how far apart two ideas are, it measures if they're pointing in the same direction. You can think of it like a compass for ideas. Concepts like running and jogging are pointing in almost the exact same direction on the meaning map, so the system knows they're super similar. So now let's put it all together. We have our GPS for words and our smart library. Let's see how they power one of the most useful AI applications today, RAG. This is where we combine our smart search with a powerful AI like Gemini to get answers that are not just intelligent, but factual. And here's the absolute key takeaway. A standard chatbot, it answers from memory. It's just pulling from the massive pile of internet data it was trained on. So if it doesn't know something, it might just make it up. We call that a hallucination. RAG completely changes the game. It forces the AI to first look up the answer in a specific set of documents that you provide. It's just like a student in an open book exam. The whole process is really simple, but it's incredibly powerful. First, you ask a question. Then, this system uses that vector search to dive into your private knowledge base and retrieve the most relevant little snippets of text. Third, it augments the prompt, basically just copy-pasting that retrieved text right into the AI's instructions. And finally, the AI generates an answer, but, and this is the important part, it's been told to base its answer only on the facts it was just handed.
And for businesses, this is an absolute game changer. All of a sudden, every single internal handbook, every report, every manual becomes instantly searchable by meaning. You can build customer service bots that give correct answers because they're grounded in your actual policy documents. This basically solves the AI's hallucination problem and finally unlocks the real value hidden in all your private data.
Okay, so what if you're thinking, this is cool, I want to try this out? Well, building a simple version of this is actually way more accessible than you might think. Let's take a quick look at the Essential Toolkit.
For anyone who wants to build a quick proof of concept, this is your shopping list. LangChain is like the conductor of the orchestra. It's a framework that helps all the other parts talk to each other. ChromaDB is your smart library, a simple vector database you can run right on your own computer. Then you need two brains, an embedding model from a provider like Google to turn your text into coordinates, and a large language model like Gemini to actually generate the final answers. Oh, and a huge pro tip. Always keep your secret API keys in a separate file called .venv to keep them safe. But before you can do any of that, you have to prep your data. See, AI models have a limit on how much text they can read at one time. You can't just give them a 500-page PDF and call it a day. The process of chunking breaks that huge document down into smaller, more meaningful paragraphs. The best tools for this act like a smart editor, splitting the document along natural breaks to keep related ideas together in the same chunk. Now, when it comes to where you actually host your vector database, you've got two main choices. For learning, prototyping, and smaller projects, running something like ChromaDB locally on your machine is perfect. It's like having your own personal workshop in the garage. But when you're ready to handle millions of documents and real users, you graduate to a managed service like what you'd find on Google Cloud. That's the industrial warehouse, built for massive scale, speed, and reliability. So there we have it. We've gone from a simple keyword matching problem to a full-blown system that can understand the meaning inside any document you give it and then ground its answers in solid facts. This technology is evolving from a search engine into a true answer engine. And that leaves us with a pretty fascinating question to think about. With this kind of power at your fingertips, what's the first thing you're going to ask?